Hello, Math 30-2. This is your lecture for Friday, September 2nd. We are going to be looking at lesson 1.4, applications of set theory, and this really moves us into problems with three intersecting sets. But before we do that, I want to look at the principle of inclusion and exclusion again, and we'll do it using this problem. So given that the number of elements in A plus the number of elements in B equals the number of elements in the union of A and B, and the number of elements in A plus the number of elements in C is greater than the number of elements in A, the union of A and C. So which sets are disjointed, which sets are intersecting, and are there sets that could be either? So let's take a look at this information in relationship to the principle of inclusion and exclusion. So we've been told that if I take A and B, add it together, it gives me the same number of elements as I would have in the union of A and B. So if I look at my principle of inclusion and exclusion, I have the union of A and B, the number of elements. Here I have all of the elements in A and all of the elements in B. When I add them together, I have to subtract out this intersection. Now, if this intersection is an empty set, that means that this doesn't apply. Then we have the equation that's left. Well, for those to be an empty set, for the intersection of A and B to be an empty set, A and B have to be disjointed. So A and B are disjointed. Now, if I look at the section A and C, I add the number of the elements in A and the number of elements in C, and that's greater than the number of the elements in A, of the union of A and C. That means that if this side here is greater, that means we haven't yet subtracted out the intersection. And so that means that set A and C must be intersecting. Now, we have been told nothing about the relationship between set B and set B and set C. So we don't know how they connect or what would happen if we added the elements in A or B and the elements in C. We don't know anything about it. So B and C could be either disjointed or intersecting. We don't have enough information. So just a way of logicking or thinking your way through the principle of inclusion and exclusion. Now on to sets of, well, three, not sets of three sets that intersect. So when Rachel surveys her grade 12 students, she finds out about how they communicate with their friends. The important thing here, it's never actually said explicitly, but the number in the universal set is 100%. You can't survey more than 100% of the grade 12 students. And so, as I say, it's not said explicitly, but we're told, but we understand that. So 66% called on a cell phone. So we have a cell phone. And the number here is 66%. We know that the number that texted, so we'll call this set C or T, that has a number of 76%. And that's kind of messy, I'm sorry. And we know that our social networking site has 34% using it. Now, in the section that says called on a cell phone and texted, so if they're called on a cell phone and they texted, that's this intersection piece between the cell phone and the texting. And it, remember, will include all three. So I'm going to jump down to this last piece of information. 12% used all three forms of communication. So that 12% sits right here in the middle, where all three overlap. Now, we know that this whole area here, the people who use their cell phone and they text, that area total is 56%. But we have to subtract out the 12% to determine what's just here in this portion where I've put the yellow. So 56 minus 12 gives us a 44. So we have 44% here. We know that 18% called on a cell phone and used a social networking site, and so that 18% is this whole piece. But 12 of those also used texting, and so we have 6 that used only cells and texting. Now, because I have all of these pieces combined, that allows me to calculate the number of people here that use only a cell phone. So I take 66 minus 44, leaves me with 22. I subtract 12, that leaves me with 10. Subtract 6, and that leaves me with 4. So I have 4% that use cell phones exclusively. Now I want to talk about the people who text and use a social networking site. So that's 19%. Again, we have to subtract the 12 that also use a cell phone, and that gives us 19 minus 12 gives us 7. Now, with that piece filled in, it allows us to determine how many people text only. So you take 76, subtract 44. Now I'm just going to pull out my calculator. We have 76, I'm subtracting 44, subtracting 12, and subtracting 7, and that gives me 13%. And I can do the same thing to determine the number who use only a social networking site. And so we have 34% altogether, and we have to take out the 6% that also uses a cell phone, the 12% that use cell phones and texting as well, and then the 7% that just text and use social networking site. And that leaves us with 9% in here. Now, we're being asked to determine what percentage of student uses all three, or sorry, at least one of these forms, which means essentially we are looking for the union of the cell phone and the texting and the social networking site. So the union of those three sets. To do that, we simply add up all of the pieces. We take 4 plus 44 plus 13 plus 6 plus 12 plus 7 plus 9, and that gives us 95%. So 95% of the students use at least one of these. that means that there are 5% of the students who use none of those to communicate with their friends, or have used none over the previous week. On to the next question. So problem solving using set theory. So here we have children with dogs, cats, or birds. So again, we have 3 overlapping sets. And I was just going to try and pick up the picture. So I think I've lost it. Just pause. I'm going to pause for just a second. Okay, I found my image with the 3 intersecting sets. So we have 24 children have a dog, a cat, or a bird. So that means my universal set has a value or a number of 28. So the number in my universal set is equal to 28. And the number that have dogs is 13. And the number that have cats is 13. And the number of children that have a bird is 13. We have 4 children that have only a dog and a cat. So this would be the intersection of the dog and the cat. So the number here is 4. And 3 children have only a dog and a bird. Remember, and is the intersection, so we have the dog intersecting with the birds, and the number of children there is 3. 2 children have only a cat and a bird, so we now have the cat intersecting with the bird, that set, and there are 2. Here we are told no children has 2 of each type of pet. So that simplifies things. We don't have anyone doubling up. Let's determine how many children have a cat, a dog, and a bird. Well, we want to know how many children have. I thought we were told that. Okay, anyway. So our universal set here, having a pet, is 34. We know the number that have dogs is 13, and the number that have cats is 13, and the number that have a bird is 13. We don't know, we're not told how many children have all of them. We don't know who all of them are, but we do know that 4 children have only a dog and a cat. So that would be only a dog and a cat. 3 children have only a dog and a bird. 2 children have only a cat and a bird. We still don't know how many belong in the middle. So if I look to find the number of children that have only a dog, I need to take 13 minus 4 minus 3 minus x. So 13 minus 4 minus 3 gives us 6, so I have 6 minus x. That's the number that have only a dog. Here with the cats, we start with 13. We can subtract out 4 and subtract out 2 and subtract out x. That leaves us with 7 minus x children having a cat only. Finally, we have our bird, 13 minus 3 minus 2 minus x, and so that gives us 8 minus x that have a bird only. We know that, I'm not sure why I got 34 here. That would be 28. Okay, so when I add each piece together, we have x minus 6 plus 4 plus 7 minus x, and I said x minus 6, but it's 6 minus x, plus 3 plus x plus 2 plus 8 minus x. When we add all of that up, it has to add to 28, because none of these children have no pets, okay? They all have a certain number of pets. So we want to simplify this, so I take 6 plus 4 plus 7, 6 plus 4 plus 7 plus 3 plus 2 plus 8. That gives us 30. And I have minus x plus x minus x. So I have 3 negative x's and plus x. So that gives me negative 2x, and that's equal to 28. I subtract 30 from both sides, so I get negative 2x is equal to negative 2, and I get x is equal to 1. So for answer A, we have one child having a dog, a cat, and a bird, having all three. And when I got confused there, it's because I wasn't paying attention to the and or the or. Or is the union of all of them, and is the intersection of all of them. So we need to be careful about that, because if you're not paying attention to those details, you can get confused like I did. Then we want to know how many children have only one pet. So let's find out how many children have a dog only. Well, we know that that's 6 minus x, and we've calculated x to be 1. So 5 children have a dog only. The cat only is 7 minus 1, which is 6, and the bird only is 8 minus 1, which gives us 7. And so when we add these together, we have 18 children that have only one pet. So 18 out of the 28. And it surprised me that the birds were the highest number, because, you know, of only pets. Okay, let's move on to a theoretical question. It's not quite so number-based. It's searching the internet. So Hillary and Liam are working on a project for their world issue class. They need to use the internet to gather information about popular culture, especially social criticism on television. Liam suggests they search for popular culture using a search engine. How can they refine their search to narrow down the number of hits? Well, if we make the number of elements, the universal set to equal all the sites on the internet. And then if we take and use set P for all of the sites containing the word popular culture and popular and culture. So it includes the words popular and culture. So that's huge. You can't get to it. So you can get fewer results if we narrow it down, and the way you narrow it down is you use popular culture and you put it in brackets. And essentially what that says, it has to have popular and culture. So this, I'm going to correct this, this should be or. Okay, when I put the quotes around it, I'm just going to use are here. So this is sites with the word popular and culture. And then if you're worried about, or you're wanting to add things about television, you can search popular culture together and television, which will give you an intersection, because if we think of T as all of the sites about television, can't spell today, all the sites about television, that when we put them together, we get the intersection of popular culture and television. And so if we think of this as so this is our universal set, and here is popular or culture, and then we limit it to popular and culture. That brings us inside here. And then we have television. And so we have this spot where they all overlap. And we have narrowed our search down so that we get quite a bit fewer. Then you might add on words like social criticism and television shows, and you could get even more and reduce it to an even smaller amount. Okay, so and really you need to take some time and learn how to use your search engines to narrow your searches down that way, which is a workshop that the library gives, so you might consider that. Let's go on. We've talked about correcting errors before, so let's do some more correcting errors. And Shannon's high school starts a campaign to encourage students to use green, quote, in quotes, transportation for traveling to and from school. At the end of the first semester, Shannon's class surveys the 750 students in the school to see if the campaign is working. They get these results. They have 370 students who use public transit, 100 who cycle and use public transit, 80 who walk and use public transit, 35 who walk and cycle, 20 students who walk, cycle, and use public transit, 445 students who cycle or use public transit, and 265 students who walk or cycle. Okay, so we're going to solve this by using this set of intersecting sets. We have 375 or 70 students that use public transit. So the number of elements in public transit is 370. So this is P here. We have 100 students that cycle and use public transit. So that's this section here. And essentially, we're not told how many students use all three. So that's again where our X comes into place. Oh, I'm wrong. I wasn't paying enough attention. We have 20 students who walk, cycle, and use public transit. And notice in solving it, the way I solve it, and there's more than one way. You can list it out in the text, go to the textbook, it'll do it separately. A different way, I always find the center. So this is the one, there's 20 students that use all three. We have cycling and walking. So now we were told that 100 students cycle and use public transit. So 80 of those 100 students use, or sorry, 20 of those students also walk. So 80 use public transit and cycling exclusively. Now we have 35 students. Okay, 80 students walk and use public transit. So if 80 students walk and use public transit, 20 of them also cycle, and so we have 60 students that use public transit and walking only. 35 students walk and cycle, 20 of them also use public transit, and so 15 walk and cycle exclusively. We're told that 445 students cycle or use public transit. So now we have to do a little bit of work. We need to find out the number of students that use public transit only. So we take the number of students who use public transit, which was 370, and we subtract out from there the students who use public transit and cycle, and then we subtract out the students that use public transit, cycle, and walk, and then we subtract out the students that use public transit and walk. And so we're left with 210 students using public transit. Now we're told that 445 students cycle or use public transit. So that's the union of these two. So now if I take each of these pieces and subtract it from 445, I can find the number of students who cycle only. So I start with 445. I subtract 210, subtract 80, subtract 20, and subtract 60. And that leaves me with 75 students that cycle only. Now we want to figure out how many students walk only. So we know that 265 students walk or cycle. Okay. So if I take my 600 or my 225 and subtract out from them the students that also cycle, I subtract 15 20. Just give me a second here. Okay, I need to back up here. So with the 445 students who cycle or use public transit, we end up with 75 who cycle. But remember, some 15 of those 75 also walk. So we have to subtract out the 15 from the 75, and that gives us 60 students who cycle only. So now we need to find out the number of students who walk only. We're told that 265 students walk or cycle. So from that 265, I need to subtract out all of the students who cycle. Whether they cycle and walk or cycle and use public transit doesn't matter, but they need to come out of the students who walk or cycle. So we start with 265, we subtract out 80, subtract out 60, subtract out 20, and subtract out 15. So that's all of the students who cycle. And I made a mistake. So let's try this again. 265, subtract 80, subtract 60, subtract 20, and subtract 15. And that leaves me with 90 people who walk. So, but of those 90 people who walk, we haven't accounted for the 60 who use public transit, and so 90 minus 60 leaves us with 30. Okay, so we now have 30 students that walk only. Ultimately, the question that we're trying to ask is how many students use green transportation, and that would be totaling up all of the numbers. So 210 plus 80 plus 60 plus 60 plus 20 plus 15 plus 30. And so let's add those up. We have 210 plus 80 plus 60 plus 60 plus 20 plus 15 plus 30. I'm getting something wrong here. Nope, everything looks good. So 475 students use some form of green transportation. Okay, here are your practice questions. Have yourselves a great long weekend, and we will talk to you on Tuesday. Bye now.